Right. Blind 75, problem 4. Container with most water. Most water. Most water test. Copy the problem. You are given an integer array of length n, array height of length n, integer array height of length n. There are n vertical lines drawn at the two endpoints of the ith line are 1 I comma 0 I comma height I. Okay, find two lines that together with the x-axis form a container such that the container contains most water. Okay, return the maximum amount of water in. Oh, it's like this. Between this, I don't know. Return the maximum amount of water. Notice that you may not slant the container. Okay. So we want as high a value. So, okay, this is basically area, right? So it's volume, but there is no third dimension. So we're basically talking area. So the length is the distance between lines. So the farther apart they are, the better. And height is the minimum of the two. So whichever is the smallest height is basically going to limit the amount of water that we can store. Right. Okay. That's cool. So thinking about the approach for 5 minutes. What time are we at? Okay. 6, 9. So yeah. So there might be two. So let's think of two contradicting cases. These two, if they were like really high, these two could store a large amount of water, which is larger than this. So we need to keep in mind the distance x. Okay, so we have an array, right? So for every, so for if I'm looking at this, the largest container this can make is the distance. Yeah. So largest container this can be part of will be maximum of, should we do it for every? Okay. We need to keep track of all the areas, right? One area is this. Hmm. Let's, I think we'll brute force this first. Uh, okay. Hmm. Hmm. Mm, number is less. So for this problem, we don't need to worry about zero length. We can minimum 2, maximum 10 to the power 5. Height can be 10 to the power 4. It's 10 to the power 4 times 10 to the power 5. Mm, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's better use longs, I guess. Length of radius 2 returns twice the minimum, twice the lesser height. Right? This kind of helps you think about the problem as it grows. So let's say there's only two rays. 90 plus 90. So 10 comma 12. Area should be 10 times 2. Right. One second. Data class for most water. These are your heights. Private. Make everything long. Times math. This is a very crappy approach, but I don't care. Hmm. The simplest case is solved. Let's think about it. Okay. So let's say we have sort the bars in order of their height. Will that work? Order ends. Mm, okay, let's say we start from the beginning. We keep track of the highest tower. So there can be a local maximum. And we keep track of the max area so far. So first two we calculated, and the third one comes. Uh, what do I need to know? Do I need to compare with both? Yeah, I need to compare it with both one comes. Do I need to compare it with all three or is the highest one? Well, if the highest one is just next to it, nope. I'm not able to think of anything other than better than order and square. Since we're short of time, that's what we'll go with. Let's go with this input. Um, test. Mm, what should be the answer in this? Heat 7. 1, 2, 3, 4, 6, 7. So I need the 56. Oh, sorry. 7, 7, 7, 7, 59. Okay. Let's refactor this a bit. And start. And H1 oh sorry, index 1, index 2. Get rid of this. 0, compute area. Return index 2 minus index 1 multiplied by math dot min of ARR heights index 1 comma heights index 2. The first test should still pass. No. Okay. Off by one error, it seems. Two, 9 minus 7. How is it 49? Okay, we are exclusive of one point, so not off by one error, but incorrect test. It's a shame. We are going to brute force this. Let's submit this. Time limit exceeded. Hmm, that figures. So we don't need to optimize it. Let's think for a minute. We do a sliding window. Start from the most extremes. What's the area? Max area so far. Okay, yeah. Let's start with the first and last values. What area? That's so the length cannot increase. Yeah, base cannot increase beyond that. And then every time we compress any of those, it has to raise the overall area. So I go to second, I compare if that increases the area. If it doesn't, uh, now in which direction do I want to move? That's the thing. Yeah, max area between I and j is this. Max area, I move one. Max area between these two is hmm, between these two is whatever it is. And max area between these two is whatever it is. Which pointer to move that? Go greedy. We'll move in the direction of whichever has greater height. Right. Yep. If we go greedy, uh, if these two, we would start looking at this and this. I'm not sure about the correctness of this. Marks so far. We only switch if we move till we find a greater than. Stop there. Calculate the area. Mm, Strategy to 90 left equals 0, 90 right equals heights dot length. Long max area equals compute area left comma right. Then while one left level yeah. If height of while height of left is less than max left equals height 0 max right equals heights right. And heights left is less than max left plus right. I'm not sure about this. I need to see the solutions. For a hint, then they do high. If it's an eventually order answer which is not efficient, that's try to use two pointers. I did that, set on the pointer that points to the lower line. What? Okay. 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 Let's try this. Always move the pointer that points to the lower line instead of this. If okay, heights of left is less than heights of right and left plus. Hmm. Okay, that's our best. Shucks, should have been able to figure that out. Okay, max area equals max dot max compute area left comma right max area. else. Right. Minus minus. Return. Yeah. Uh, that, okay, the hook was you have to compare the heights of the current pointers and move the one that makes sense. That's what I couldn't figure out, right? Whether to move left or right. Okay, I'll remember that. Stop recording.